Well, let us discuss the derivatives of inverse trigonometric functions. Inverse trigonometric functions. As we know that sin x, cos x, tan x, etc. they are all said to be trigonometric functions. Sin x, cos x, tan x, secant x, cosecant x, cot x, they are all said to be trigonometric functions. We have another set of functions, they are said to be inverse trigonometric functions. So let us know how to define the inverse trigonometric function. Suppose if x is equal to sin y, or we can take y is equal to sin x, any variables, y is equal to sin theta or x is equal to sin theta, like that. If this equation, that is y is equal to sin x, satisfies this condition, that is minus pi by 2 less than or equal to x less than or equal to pi by 2, or this domain minus 1 less than or equal to y less than or equal to plus 1. If these two conditions are satisfied by this equation, then we can say that y is equal to sin x can be taken as x is equal to sin inverse y. It is read as what? X is equal to sin inverse y. Under which condition? Under this condition. If x is equal to, if y is equal to sin x, and if this equation is verified or satisfied these two conditions, then we can say that x can be taken as sin y. This is, we should not call it as power. It is sin inverse y. Sin inverse y. Like that, we can define all other inverse trigonometric functions. All other trigonometric functions. They are all said to be principal values of sin. So, why this condition? If I take sin of any value, its value varies from plus 1 to minus 1 or minus 1 to plus 1. To get plus 1, I should take sin 90, correct? Sin 90 is equal to what? Plus 1. Sin of minus 90, you will get minus 1. The maximum value of sin of any value is plus 1. The minimum value is what? Minus 1. The sin function always varies plus or minus 1. As we know that sine wave, it goes to maximum of what? Plus 1. And it goes to minimum of minus 1. Like that. This is sine wave. Maximum is plus 1, minimum is minus 1. The maximum and minimum values of sine are plus 1 to minus 1. Hence, this value should satisfy this equation. Therefore, we can call it as sin inverse y. It is the inverse trigonometric functions. For sin x, we will write sin inverse is sin inverse x. For cos, we will write cos inverse x. For tan, we will write tan inverse x. For cot, we will write cot inverse x. For secant, we will write secant inverse x. Similarly, for cosecant, we will write cosecant inverse x. These are the inverse trigonometric functions. How we will call it as trigonometric function? In the same way, we will call it as inverse trigonometric functions. For these inverse trigonometric functions, we have a set of formulas. As here, we studied that sin square x plus cos square x is what? Sin square x plus cos square x is equal to 1. In the same way, here also we have formulas like sin inverse pi by 2 plus cos inverse pi by 2 is equal to 0. So 1. Sin inverse x plus cos inverse x is equal to 1. Like that, we have a different set of formulas for trigonometric functions as well as for inverse trigonometric functions. Our aim is to, in this class, our aim is to get the derivative of these two functions. Derivative of sin inverse x, derivative of cos inverse x, derivative of tan inverse x. So this we have not studied in the earlier classes. That's why I am giving you just introduction of inverse trigonometric functions. Okay, you just know it as this is a sin inverse x, cos inverse x, tan inverse x, secant inverse x, cosecant inverse x, cot inverse x. They are all said to be what? They are all inverse trigonometric functions. Okay. Next, let us get the derivative of such inverse trigonometric functions. Derivatives of inverse trigonometric functions. What is differentiation of sin inverse x? What is differentiation of cos inverse x? Let I will take y is equal to sin inverse x. For that, I should get dy by dx. As we know that x is equal to sin y, therefore y is equal to what? Sin inverse x, correct? If y is equal to sin inverse x, we should take it as x is equal to sin y. Vice versa is also true, right? This is inverse trigonometric functions. I will write according to the definition. X is equal to sin y. X is equal to what? Sin y. The function is or what? The function is in y. X is in y. Differentiate x with respect to y. Suppose if the function is in y, what do you get? We get dy by dx, correct? F dash x or some other function. In the same way, if I differentiate this with respect to y, I will get dx divided by dy, correct? For y is equal to f of x, if I differentiate y with respect to x, I will get dy by dx. The same way, if x is in what? Y. If I differentiate this with respect to y, I will get differentiation of x is what? Dx by dy is equal to, as we know that differentiation of sin x is what? Cos x. Here we have to write cos y. Differentiation of sin x is what? Sin x differentiation is cos x. If it is in y, if it is this is y, I should take it as cos y. The same way, here it is taken as dx by dy is equal to sin y, whose derivative is cos y. I will take their reciprocals. So I am just changing denominator into numerator or numerator into denominator. 1 divided by dx divided by dy. Then it becomes what? 1 divided by cos y. 1 divided by cos y. Correct? So denominator of denominator becomes what? Numerator. It becomes dy by dx is equal to dy by dx is equal to 1 by cos y. Cos y. As we know that sin square x plus cos square x is what? Sin square theta plus cos square theta is 1. Therefore, cos square theta is what? Cos square theta is 1 minus sin square theta. Correct? What is cos theta? Cos theta is root of 1 minus sin square theta. According to that, 1 divided by cos y become what? Cos y become 1 minus sin square y. 1 by root of 1 minus sin square y. Now 1 divided by root of 1 minus, substitute value of sin y. What is sin y? Sin y is equal to what? x. Therefore, sin square y is what? Sin square y is x square. That means differentiation of sin inverse x. What is y? Y is equal to sin inverse x. Differentiation of sin inverse x is what? 1 divided by root of 1 minus x square. We can say derivative of sin inverse x is 1 divided by root of 1 minus x square. Okay. D by dx of sin inverse x is equal to 1 by root of 1 minus x square. By following the same procedure, we can get the derivative of other inverse trigonometric functions. So derivation is out of scope. Just I have given you one. Based on that, if you want, you can take the derivative of others. So derivation is not necessary. Please remember directly the derivatives of inverse trigonometric functions, right? Differentiation of sin inverse x is what? 1 by root of 1 minus x square. D by dx of cos inverse x. In the same way, we will get it as minus 1 divided by root of 1 minus x square. For sin inverse x and cos inverse x, we have same derivatives. Only the difference is what? Only the difference is minus. Got it? The same way, d by dx of tan inverse x, it is 1 by 1 plus x square. You can easily remember it. How? For sin inverse x is root of 1 minus x square. For tan inverse, there is no root. Correct? Here is minus. Here we will have plus. Only that difference. We don't have root, and here is plus. And d by dx of cot inverse x. For cot inverse x, it is minus of 1 divided by 1 plus x square. D by dx of secant inverse x, it is 1 by x into root of x square minus 1. See, for remembrance, you can have clue. For sin inverse x is what? Root of 1 minus x square. For secant inverse, we have extra x at the denominator and inside the root. These two terms are interchanged. Correct? D by dx of cosecant inverse x. It is minus 1 divided by x into root of x square minus 1. Differentiation of sin inverse x with respect to x is what? 1 by root of 1 minus x square. For cos inverse, it is minus 1 by root of 1 minus x square. For tan inverse x, it is 1 by 1 plus x square. For cot inverse, minus 1 by 1 plus x square. For secant inverse x, it is 1 by x into root of x square minus 1. For cosecant inverse, it is minus 1 by x into root of x square minus 1. Just remember these derivatives. Okay. By using inverse trigonometric functions, we can work out problems. So as we discussed in the earlier classes, rules of differentiation, correct? Function of function, all the rules of differentiation are applicable to inverse functions also. If it is in product form, we have to use product rule. If it is in quotient form, we have to use quotient rule. If it is in sum or difference rule, we have to use sum or difference rule. If it is in the function of a function, we should use chain rule or function of a function. Let us work out few problems. Okay. Differentiates the following with respect to x. Differentiate the following functions with respect to x. Y is equal to 5 into sin inverse x. This is of what form? It is of second rule. Correct? Constant into function. How it is differentiated? Keep the constant as it is, differentiate sin inverse x. What is derivative of sin inverse x? It is 1 by root of 1 minus x square. ಇಲ್ಲಿ trigonometric functions ಗೆ algebraic functions ಗೆ differentiation rules ಏನೇನ್ ಅಪ್ಲೈ ಆಗುತ್ತೆ, chain rule ಎಲ್ಲಾ ರೂಲ್ಸ್ ಇಲ್ಲಿ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ಸ್ ಅಪ್ಲೈ ಆಗುತ್ತೆ. ಅಷ್ಟು ಮೈಂಡ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ಸಾಕು. ಡೆರಿವೇಟಿವ್ಸ್ ಅನ್ನ ಮಾತ್ರ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. differentiation derivatives ಇದನ್ನ ಡಿರೈವ್ ಮಾಡಿದ್ವಲ್ವಾ, that is not necessary, right? So according to that, dy by dx is equal to what? Keep 5 as it is. Differentiation of sin inverse x is what? 1 by root of 1 minus x square. It is 5 by root of 1 minus x square. Y is equal to 4 tan inverse x minus 3x plus 2. So this inverse function is combined with the ordinary terms. So you differentiate according to the given term. So basically it is of what rule? Sum or difference rule. Sum or difference rule. We have to differentiate individually. Correct? Keep 4 as it is. Differentiation derivative of given y is equal to 2 cos inverse x minus 3 tan x plus 4 cosecant inverse x minus 3. You can have any number of terms in the combination of what? Algebraic terms, x square, x cube, trigonometric functions as well as inverse trigonometric functions. It is of what form? This is u minus of v plus w and so on. Correct? Sum or difference of 4 terms. We have to use which rule? Sum or difference rule. Okay. The first term, it has to be differentiated. How it is? Constant into x term. So keep constant as it is. Differentiate cos inverse x. What is differentiation of cos inverse x? It is 1 by root of 1 minus x square. Next symbol is what? Minus 3 into differentiation of tan x is what? Secant square x plus 4 into what is differentiation of cos inverse x? Sorry, cosecant inverse x. For cosecant inverse x, it is minus 1 by x into root of x square minus 1. Minus, we have only constant. Differentiation of constant is what? 0. So finally, it reduces to minus 2 by root of 1 minus x square minus 3 secant square x plus into minus minus 4 divided by x into root of x square minus 1. Right? Next one, y is equal to 5x plus 3 cot inverse x minus 7, or you can take 5 by x. It is also sum or difference rule. Dy by dx is equal to 5 into what is differentiation of 1 by x? We have to use 1 by x to the power of n formula minus n. What is n? Power of x by x to the power of n plus 1 plus 3. For cot inverse x, it is minus 1 by 1 plus x square. For minus 7, constant, only constant is there. Differentiation of constant is 0. This is minus 5 divided by x square plus into minus minus 3 divided by 1 plus x square is answer. Next, y is equal to root x into tan inverse x. The given function is in which form? Observe the problem. It is root x into tan inverse x. Correct? Root x into tan inverse x means we have to use product rule. We have to use product rule. What the product rule says? Differentiate on both sides with respect to x. Root x into root x is u, root x is u, this is v. That is u into d by dx of tan inverse x, correct? Plus v into, what is v? Tan inverse x into d by dx of what? Root x. We have applied product rule. U into first function into differentiation of second plus second function into second function is v, d by dx of root x. Now wherever we have root, just differentiate it. Sorry, wherever we have d by dx, that term is to be differentiated. Other terms keep as it is. Differentiation of tan inverse x is 1 by 1 plus x square. Plus keep tan inverse x as it is. Differentiate root x. D by dx of u. That is 1 by 2 root of x. This is final answer. Okay. Y is equal to e to the power of x into sine inverse x. This is u, this is v, right? Differentiate with respect to x. We get what? E to the power of x into d by dx of what? Sine inverse x. Plus sine inverse x into d by dx of what? E power x. U into d by dx of v plus v into d by dx of u. It is e power x. Differentiation of sine inverse x is what? Root of 1 minus x square. 1 by root of 1 minus x square. Plus sine inverse x into differentiation of e power x is e power x. We can take e power x common. 1 by root of 1 minus x square plus sine inverse x. Got it? Like that, if it is in product form, we have to use product rule. If it is in quotient form, we have to use quotient form, quotient rule. Y is equal to sine inverse x divided by x square plus 3. It is of what form? It is in the quotient form, right? U divided by v. What is u? Sine inverse x. What is v? This one. dy by dx is equal to x square plus 3 u, sorry, that is v into d by dx of what? Sine inverse x minus sine inverse x, that is u into d by dx of what? V. What is v? It is x square plus 3 all divided by x square plus 3 whole square, that is v square. V into d by dx of u minus u into d by dx of v divided by v square. So x square plus 3. Differentiation of sine inverse x is what? 1 by root of 1 minus x square minus. Keep sine inverse x as it is. Differentiate x square. Differentiation of x square is 2x plus differentiation of 2 is what? Sorry, 3. Differentiation of 3 is constant. So 3 is constant whose derivative is 0. All divided by x square plus 3 whole square. So finally, you can write like this: x square plus 3 divided by root of 1 minus x square minus 2x into sine inverse x all divided by x square plus 3 whole square. Right? So like that, if they are in quotient form, we have to use quotient rule. If they are in product form, we have to use product rule. So let us work out 1 or 2 problems on chain rule. If the inverse functions are involved in chain rule, we have to differentiate according to that. Say d by dx of sine inverse function. For differentiation of sin inverse x, it is 1 by root of 1 minus x square. Correct? Suppose in place of x, if we have a function, then how it is to be differentiated? It is 1 by root of 1 minus function square. In place of x, we have a function, right? Replace x by function into, at the end, we have to differentiate the function, right? So this concept is extended to all the inverse trigonometric functions. See, d by dx of tan inverse function is what? 1 by 1 plus function square into d by dx of function. D by dx of secant inverse function is what? 1 by function into root of function square minus 1 into d by dx of function. Got it? So this is called chain rule. Okay? Take the examples. Y is equal to sine inverse of cos x. The given function is what? Y is equal to sine inverse of cos x. Find dy by dx. Okay, simple problem. For sine inverse a function, for sine inverse function, what is the answer? It is 1 by root of 1 minus function square into what? D by dx of function. So compare this. What is function? It is function. Cos x is function. Therefore, on differentiating, we get dy by dx is equal to, for sine inverse function, it is 1 by root of 1 minus function square. What is function? Cos x. Into d by dx of function. What is function? Cos x. That is equal to, as we know that sin square theta plus cos square theta is what? 1. Or sin square theta is what? 1 minus cos square theta, or cos square theta is what? 1 minus sin square theta. This is trigonometric identity. This is equal to 1 minus cos square x is what? 1 minus cos square x is equal to sin square x root of sin square x into differentiation of cos x is what? Minus sin x. Here square root get cancelled. What is remaining? Minus sin x divided by, after get cancelling root and square, you have sin x. Sin x again cancel. What is remaining? 1 is answer. Okay. We will extend this idea for other functions also. Y is equal to tan inverse of root x. Y is equal to tan inverse root x. So this is of what form? Tan inverse function form, correct? On differentiating, we get dy by dx is equal to, what is differentiation for tan inverse x? It is 1 by 1 plus x square, correct? In place of x, we have function. Change these two for function and differentiate the function. 1 divided by 1 plus function square. What is function here? In place of function, we have root x square. Into d by dx of what? Root x. D by dx of root x. Okay. This is square root cancelled. 1 by 1 plus x into differentiation of root x. It is 1 divided by 2 root of x. So finally, it is 1 by root x into 1 plus x. Right? Y is equal to cosecant inverse of e power x. Cosecant inverse of e power x. It is of what form? cosecant inverse function, correct? Derivative of cosecant inverse. You look the list. What is derivative of cosecant inverse? It is minus 1 by x into root of x square minus 1. In place of x, we have function. What is function? E power x minus 1 divided by function e power x into root of e power x square minus 1 into what? D by dx of e power x. Right? That is minus 1 by e power x into root of e power x square minus 1 into differentiation of e power x. It is e power x. So this e power x get cancelled. What is remaining? Minus 1 by root of e power x whole square means e power 2x minus 1. This is answer, right? Next one, y is equal to tan inverse of 3x divided by 1 plus 3x. It is of what form? Y is equal to tan inverse of 3x divided by 1 plus 3x. Tan inverse function, correct? Tan inverse function dy by dx is equal to 1 by 1 plus function square. What is function? 3x divided by 1 plus 3x into what? Into d by dx of function. The function is 3x by 1 plus 3x. This is square, correct? For tan inverse x, it is 1 by 1 plus x square. In place of x, if it is function, you have to take 1 by 1 plus function square into d by dx of function, right? You can simplify the denominator. See, 1 by 1 plus 3x whole square is what? 9x square. 3 square x square divided by 1 plus 3x whole square into, how to differentiate this? 3x by 1 plus 3x is in the quotient form, correct? To differentiate this, we have to use quotient rule. Use quotient rule. 1 plus 3x into d by dx of 3x minus 3x into d by dx of 1 plus 3x whole divided by 1 plus 3x whole square. Just we have written according to quotient form. Here, if you want, you can take LCM. 1 plus, what is LCM? What is LCM? 1 plus 3x whole square is LCM. Correct? 1 by 1 plus 9x square by 1 plus 3x whole square. If the denominators are different, their product will become LCM. Then how to write numerator? Just into this 1 plus 3x whole square plus 1 into 9x square plus 1 into 9x square into 1 plus 3x. Differentiation of 3x is what? 3 into 1 minus, keep 3x as it is. Differentiate this. Differentiation of 1 is 0 plus 3x, 3 into 1 whole divided by 1 plus 3x whole square. Compare these two terms. It is denominator is what? 1 plus 3x square. Here, denominator of denominator is what? 1 plus 3x square whole square. They get cancelled. Finally, 3 into 1, 3 plus into plus plus 3 into 3, 9x plus into minus minus 3x into 3 is 9x whole divided by 1 plus 3x whole square plus 9x square. If you want, you can expand it according to a plus b whole square. A square plus b square plus 2ab, 2 into a into 3x plus 9x square plus 9x minus 9x get cancelled. What is remaining? It is 3 divided by 1 square is what? 1 plus 2 into 3 is 6x. If I expand it, 3 square x square. 3 square is what? 9. 9x square. 9x square plus 9x square is what? 18x square. So this is final answer. Okay. So this problem, y is equal to x square or root of 1 minus x square into sine inverse x. The problem is of which form? See the given problem, it is of which form? It is of product form, right? There are two terms which are in product. This is u, this is v. How to differentiate this? Use product rule. What the product rule says? First function u into d by dx of v plus v into d by dx of what? D by dx of u. Then keep this as it is. Root of 1 minus x square into differentiation of sine inverse x is what? 1 by root of 1 minus x square. Plus keep sine inverse x as it is. Differentiate this. How to differentiate the root of 1 minus x square? It is of root function form, correct? It is of root function. Is 1 by 2 root of function into d by dx of function, right? According to that, it is 1 by 2 root of 1 minus x square into d by dx of function. What is function? 1 minus x square. These two are common, they get cancelled. So 1 is remaining because the ratio is cancelling. Plus sine inverse x divided by 2 root of 1 minus x square into differentiation of 1 is 0 minus differentiation of x square is 2x. This two cancel. So finally it is 1 plus into minus minus sine inverse x divided by root of 1 minus x square. This is the answer. Right? Y is equal to tan inverse x square divided by 1 plus x square. It is of what form? It is of the quotient form, correct? Basically, it is in the quotient form. Use quotient rule. Dy by dx is equal to 1 plus x square v into d by dx of what? Tan inverse x whole square minus u is tan inverse x whole square into d by dx of what? 1 plus x square all divided by v square. V is 1 plus x square whole square. Keep the first term as it is. Differentiate the second term. You just observe the second term, derivative term. What it is? It is function to the power of n. Correct? Like x square. Tan inverse x whole square. It is differentiated using chain rule. N into function tan inverse x to the power of 2 minus 1 into d by dx of function. Correct? Function to the power of n minus, keep this as it is, tan inverse x whole square. Differentiation of 1 is 0. For x square, it is 2x. All divided by 1 plus x square whole square. The next step, we can simplify it. Wherever we have d by dx, that is differentiated. One plus x square into 2 tan inverse x into 2 minus 1 is 1. Therefore, 2 tan inverse x is remaining. Differentiation of tan inverse x is what? 1 by 1 plus x square. For tan inverse x, it is 1 by 1 plus x square. Minus tan inverse x whole square, 0 plus 2x. That is minus 2x into tan inverse x whole square. All divided by 1 plus x square whole square. Is it right? Here, these two get cancelled. So finally, 2 tan inverse x. If you want 2 tan inverse x, you can take common. 2 tan inverse x, 2 tan inverse x whole square is there. 2 tan inverse x common. What is remaining? 1 minus 2 is outside. Among tan square, 1 tan inverse x is here. Remaining is x into tan inverse x all divided by 1 plus x square whole square. This is the quotient rule as well as chain rule. If y is equal to tan inverse of root of 1 minus cos 2x by 1 plus cos 2x. It is function of function param. It is tan inverse of root of function. The function is in quotient param. If I do it according to chain rule, it takes more number of steps. We want derivative. We can get it in substitution method also. In the compound angle, if it is in this form 1 minus cos 2 theta, it should be taken as 2 sin square theta. For 1 plus cos 2 theta, you can take it as 2 cos square theta. If it is in this form 1 minus cos theta, not 2 theta, if it is only theta, this becomes submultiple angle 2 sin square theta by 2. For 1 plus cos theta, it becomes 2 cos square theta by 2. If I use this formula, it will be very easy to get simplified form and finally derivative is obtained. Let's substitute the values of what? This 1 minus cos 2x is what? 2 sin square x, right? 1 plus cos 2x is 2 cos square x. 2 to get cancelled. So it is tan inverse of root of sin square by cos square is tan square. This square and root get cancelled. As we know that sin inverse of sin theta is always theta. In the same way, tan inverse of tan theta is also theta under some condition. So tan inverse of tan become x only. See, the function become what? X. Then you can easily differentiate. D by dx of x is what? 1. In simple way, you get the answer. Say this one, y is equal to log of tan inverse of root of 1 minus cos x by or cos theta by 1 plus cos theta. Find dy by d theta. Why it is theta? The function is in theta, right? Use this submultiple angle formula. It will be easily simplified. So y is equal to log of tan inverse of root of 1 minus cos theta is what? 1 minus cos theta is 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2. Right? 2 to cancel. Y is equal to log of tan inverse of root of sin inverse A by cos inverse A is what? Tan inverse A. Correct? Root of tan inverse theta by 2. Sorry, tan square theta by 2. This square root get cancelled. So it become what? Log of tan inverse of tan theta by 2. So according to tan inverse of tan theta is theta. It becomes what? Tan inverse of tan get cancelled. It is log of theta by 2. Now you can differentiate with respect to what? Theta. Differentiate y with respect to theta. You will get what? Dy by d theta. Therefore, dy divided by d theta is, for log, it is 1 by theta by 2 into d by d theta of theta by 2. Log of function, that is treated as what? Log of function. 1 by function into d by d theta function, that is 1 by theta by 2 into differentiation of theta by 2. For theta 1 by 2 remains as it is. This 2 cancel. So answer is 1 divided by theta. Right? So like that we can use the concept of chain rule and the rules of differentiation. If y is equal to sine inverse of 2x divided by 1 plus x square, show that dy by dx is equal to 2 divided by 1 plus x square. To get the required derivative, if I go according to the regular method, I should take it as sine inverse of function. After that, it has to be differentiated by quotient rule, correct? But here, if I go in other method or substitution method, it will be very easy to get the answer. So, how to substitute? What to substitute? 2 tan theta by 1 plus tan square theta. We have formula 2 tan theta by 1 plus tan square theta is what? Sin 2 theta. 1 minus tan square theta by 1 plus tan square theta is what? Cos 2 theta. 2 tan theta by 1 plus tan square theta is what? 1 minus tan square theta is tan 2 theta. Use these formulas. It will be easy to get the required answer. I am just substituting x value. Put x is equal to tan theta. If I take x is equal to tan theta, therefore I need theta. So theta become what? Inverse trigonometric formula. If x is equal to tan theta, therefore theta is equal to what? Tan inverse x. Correct? Substitute here. So y is equal to sine inverse of what? 2 tan theta divided by 1 plus tan square theta. That is sine inverse of, according to this rule, sine 2 theta is what? 2 tan theta by 1 plus tan square theta. Therefore here it is sine 2 theta. Again we have this rule, no? Sine inverse of sine theta is theta. Cos inverse of cos theta is theta. Tan inverse of tan theta is theta. By using this, sine inverse of sine theta is what? Theta. Therefore, sine inverse of sine 2 theta is what? 2 theta. I cannot differentiate this with respect to x because we don't have x. But theta is expressed in x here. That has to be substituted. What is theta? Theta is tan inverse x. 2 into tan inverse x. Now we can easily differentiate. Therefore, on differentiating, we get dy by dx is 2 into differentiation of tan inverse x is what? 1 by 1 plus x square. Finally, it is 2 by 1 plus x square. If you take this problem, y is equal to cos inverse of 1 minus x square by 1 plus x square, you will get same answer. You will get same answer. Prove that dy divided by dx is equal to 2 by 1 plus x square. To get this answer, we have to take same substitution. You have to use this and this formula. You will get the same thing. Y is equal to 2 tan inverse x. For that, answer is 2 by 1 plus x square. If y is equal to tan inverse of 2x divided by 1 minus x square, prove that dy by dx is equal to 2 divided by 1 plus x square. These two problems are solved according to the same substitution method. You take same substitution, x is equal to tan theta, therefore theta becomes tan inverse x. If I substituted here, it becomes what? See, cos inverse of 1 minus tan square theta, 1 minus tan square theta by 1 plus tan square theta, it is what? Cos 2 theta. Cos inverse of cos 2 theta is what? Theta. Finally, you will have 2 theta. If I take theta is equal to tan inverse x, then differentiating, we will get same answer. Here also, if take x is equal to tan theta, 2 tan theta by 1 minus tan square theta, it is what? Tan 2 theta. Tan inverse of tan 2 theta is what? 2 theta. So 2 theta, 2 into tan inverse x. Differentiating, you will get 2 by 1 plus x square. Right? Y is equal to tan inverse of 1 minus x divided by 1 plus x. Prove that dy by dx is equal to minus 1 by 1 plus x square. This can also be done by regular method or by substitution method. If you use substitution method, it will be easy to get the answer. What substitution? Again, you take x is equal to tan theta. If I take x is equal to tan theta, therefore theta becomes what? Theta become tan inverse x. Right? Next, on substituting, y is equal to tan inverse of 1 minus tan theta by 1 plus tan theta. Right? As we know that tan 45 is what? Tan 45 is 1. Correct? In place of this one, I will take tan 45 or 5 by 4 minus tan theta divided by 1 plus, keep 1 this as it is, don't substitute it as tan 5 by 4. If you substitute tan 5 by 4, it becomes other form. So we need to be converted this into a standard form. I will tell you the standard form. Plus for tan theta, if I multiply with 1, is there any change? No. In place of 1, I will write tan 45. So tan 45 is what? 1. 1 into tan theta is what? Tan theta. Now, the bracket is of this form. Tan A minus tan B divided by 1 plus tan A tan B. Correct? Tan A minus tan B by 1 plus tan A tan B is what? It is tan of A minus B. We have to use this formula. Then it becomes y is equal to tan inverse of tan A minus tan B by 1 plus tan A tan B is what? Tan of A. A is pi by 4 minus B. B is theta. So tan inverse of tan, it get B equal to pi by 4 minus theta, or pi by 4 minus what is theta? Theta is b tan inverse x. Now you can differentiate. On differentiating, you get dy by dx is equal to differentiation of pi by 4. What is pi by 4? It is constant. Correct? Whose derivative is what? 0. Minus differentiation of tan inverse x. It is 1 by 1 plus x square. So you are getting 1 by 1 plus minus of 1 by 1 plus x square. Okay. If they give the same problem like this, y is equal to tan inverse of 1 plus x by 1 minus x, what answer you will expect? Show that dy by dx is equal to 1 by 1 plus x square. Only the sign differs. Here is minus, you will get minus. Here is plus, you will get plus. Which formula you will be getting? Tan a plus tan b by 1 minus tan a tan b, that is tan of a plus b. So a plus b, pi by 4 plus theta plus tan inverse x, after differentiating 0 plus 1 by 1 plus x square. Correct? Like that, on the inverse trigonometric function, we can work out many problems. Right? So based on this concept, you work out more number of problems, then it will be easy to remember the derivative of trigonometric functions, and it will be easy to solve the given problems, right? So with this, I am concluding my today's class. If you have any doubt, please raise your questions.